All right, number 9, we have 9 parts. We can see A through I. We're going to use the graph of G in the figure. Find the following values, state that they do not exist, or if they do exist, and then we'll explain why. So first we want to find G of 1, and so we go to the x-axis, find 1, and we trace up. The first solid point we hit is at the value of 4. So G of 1 is equal to 4. Part B, we're going to find the limit. This is a left side limit, so we're going to find the value of G of x, the limit of G of x as x approaches 1 from the left. So as I'm tracing this graph from left to right and getting close to 1 on the x-axis, this line is getting close to a y value of 2. And so we will say the left side limit is 2. Then we want to find the right side limit. So the limit of G of x as x approaches 1 from the right hand side. So we're going to the right side of 1, and here's the line, and we're going toward 1 from the right, and we're getting close, and we're just staying equal to 4. We're just on the line y equals 4, and we're just staying there and still getting close to 4. Part D says, what is the limit of G of x as x approaches 1? So we're approaching left side, and you can see that these points are disconnected. There's a big gap, a jump. So this limit does not exist because they don't both go to the same value. So we'll say the limit does not exist because the left side and the right side limit are not equal according to the definition. E, we want to find G of 3. And so we go to the x-axis, find 3, and we trace it up, and the first solid point we hit is at a y value 2. So we will say G of 3 is equal to 2. F, we want to find the left-hand limit, so the limit of G of x as x approaches 3 from the left. So we're coming from left going to right. And so as I'm going from the left-hand side going toward 3, this is where the line is. We're just staying flat on the y value of 4. So we would say that the limit left-hand side G of x as it approaches 3 is equal to 4. Then we want to find the right side limit, so the limit of G of x as x approaches 3 from the right. So we're coming from right going toward the left, and as we approach 3 from the right hand side, we are going toward 2. And then we want to find the G of 4 value, so I go to the x-axis 4, trace it up, I hit the line at a y value of 3. And then the final part, we want to find the limit of G of x as x approaches 4. So as we approach 4, here's the point 4. So from the left side, we are approaching 4. From the right side, we are approaching 4. They both approach the same value. So we would say the limit of G of x as it approaches 4 is equal to 3. Okay, they're both approaching the same number, left and right. We want to look at this graph, and it says the heavy side function is used in engineering applications to model flipping a switch as the function follows. So we have h of x, 0 if x is less than 0, and then we have 1 if x is greater than or equal to 0. And then it says sketch the graph of h of x on the interval -1 to 1. And then it says, does the limit h of x exist as x approaches 0? So when we are less than 0, okay, we are at 0. So that means from -1 to 0, we will be a horizontal line at 0. So that would be like this. However, because it is less than, we would have an open circle. So I'm looking for between -1 and 0 to be a horizontal line but open circle. So the only one that matches right now is D. But let's check the second part. It says we're going to be at 1 when we're greater than 0. So when I get greater than 0, greater than or equal to 0, that is, I'll be at this line. So D looks good. And then it wants to know, does the limit exist at 0? So if you look at this graph, as I approach 0 from the left, I'm getting close to 0. As I approach 0 from the right, we're getting close to 1. And those are not the same, so we will say the limit does not exist. So no, as we approach 0 from the left, we go to 0, and as we approach 0 from the right, we go to 1. So B shows the correct explanation.